Hey guys, we're going to get our hands dirty a little bit today. We're going to try to graph functions by hand without the calculator, and we call this the point plotting method, which is a fancy long-winded way of saying, hey, we're going to construct a table of values. Now, I think by kind of opening the hood, so to speak, and getting our hands dirty and greasy, is it gives us a better appreciation for why these functions behave the way they do. It's going to deepen our understanding and, again, solidify that foundation that we want before we go into higher levels of math. So today we're going to see two types of functions we want to look at. I'm going to throw in a quadratic function at us, and I'm going to throw an absolute value function at us. And we're just going to make a table from x equals -3, one by one, until we get to x equals 3, and then plot those points. So this is a very underrated technique in my opinion, especially when it comes to developing a really deep understanding of these functions. And so, we are definitely going to get our hands dirty. So first, what we're going to do is we're just going to find several ordered pairs that are what we call solutions, points that satisfy those equations. We're going to plot those points on our normal coordinate grid system, and we're going to connect them as smooth as necessary. Now, one thing I will say is when we go to do these absolute values should have like this sharp V shape to them, and so they won't be as smooth as your typical quadratic. So let's dive in. Whoa. Okay, so we've got this function y equals 2 minus x squared, and I've created, this is kind of how I prefer to set up my tables. It kind of gives me enough room, hopefully, to, substitute and crunch. So I'm thinking y equals 2 minus a -3 squared. And I just think it's always such a safe, great idea to substitute your numbers within the parentheses. So when I square the -3, that makes 9. 2 minus 9 makes -7. So -3 comma -7 is my first ordered pair. We've got y equals 2 minus -2 squared. 2 minus 4 makes -2. So we're probably not going to win any awards for like the sexiest math process here today or anything like that, but it is going to pay off. 2 minus 1 makes 1, and so we got -1 comma 1. Y equals 2 minus 0 squared is 2. So 0 comma 2. I'll tell you what, it's very possible that I'm going to screw one of these up and make a mistake, and then you guys can laugh at me. Let's see, 1 comma 1. I feel the graph kind of turned there at 0, 2, and it's starting to come back up, so to speak. 2 minus 4 is going to make -2. And y equals 2 minus 3 squared. 2 minus 9 makes -7 again. So this looks like a really nice symmetric parabola. And if we go plot these points, now I'll give you a little ninja tip here. See how this x squared was negative? So that negative in front of the x squared tells me not only do we have a parabola, but it's going to be one of those parabolas that opens downward. And so that's kind of what I'm expecting as we get going here. Oh, goodness gracious, I forgot to change. Okay. So I want to start with -3, -7. Might as well spice up the color a little bit here. -3, -7. And then I've got -2, -2. We've got -1, 1. We've got 0, 2, 1, 1, 2, -2, 3, 7. And again, we know it's a parabola because of the x squared, so it's going to be really smooth. We want to make sure this vertex isn't too sharp. And looks like we've got ourselves a really nice downward opening parabola. So it looks like we've got a y-intercept of 2. The x-intercepts are actually going to be, let's say, like this one somewhere between 1 and 2. This one's somewhere between -1 and -2. It's actually going to be plus or minus radical 2 if I set that function equal to 0. Again, it opens downward. I think those are all the main characteristics that we want to hit on. So in our next example, we're going to deal with an absolute value. And again, we're just going to kind of grind our way through this bear by substituting. So we've got -3 minus 1 minus 2. Now, -3 minus 1 is going to make -4. Once you take the absolute values, that transforms it into a +4. 4 minus 2 makes 2. So -3 comma 2. All right. Again, substituting a negative number is always more challenging than substituting a positive number, it seems like. So again, let me emphasize, negative 2 minus 1 makes negative 3. Now, the absolute value of negative 3 makes positive 3. 3 minus 2 makes 1. So negative 2 comma 1. Negative 1 minus 2. So I think absolute value of negative 2 makes 2. 2 minus 2 makes 0. Y equals 0 minus 1 minus 2. So that's going to make negative 1. 1 minus 1 makes 0. 0 minus 2 makes negative 2. So we got 1 minus 2. And let's see. 2 minus 1 makes 1. 1 minus 2 makes negative 1. Felt like the graph kind of turned right there. Whoops, that's supposed to be a 1. And then the last one here, we'll go 3 minus 1 makes 2. 2 minus 2 makes 0. Yeah, it feels like it's starting to come back around, so to speak. All right. So, and I'm going to put a star right here. That 1, negative 2 feels like it was the vertex or the turning point. But again, these absolute values are going to be that sharp V as opposed to the smooth parabola that we saw earlier. So negative 3 comma 2. Negative 2 comma 1, negative 1, 0, 0, negative 1, 1, negative 2, and then it turns 2, negative 1, 3 comma 0. So it's going to be real straight in this direction. It's going to be real straight in this direction here, and just going to make a real nice V. Down the road, we're going to talk about rewriting this absolute value function as a piecewise function, but we'll cross that bridge when we get there. So I'll tell you what, as you develop your confidence and your level of comfortability with plugging points in and evaluate them, there's nothing that the SAT or an AP exam can throw at you that you're not prepared to graph, as long as we are mentally tough enough to kind of grind our way through it. All right. Good luck. We'll catch you tomorrow.